If you've ever tried adding AI models to your applications, you'll notice that we actually have a huge number of choices. We can choose from GPT, Gemini, Claude, and several other models and versions that are being released every day. Ideally, we would want the flexibility to update the AI model we use to keep up with whatever is currently the best in the market. But switching between these models can be a real headache because each of these models comes from companies that have their own APIs, and we would have to update our application code every time we want to switch between them. But there actually is a way to make this much easier. This is where applications like OpenRouter come in. You can think of this as a universal adapter for large language models. This provides us with a single API that we can add to our applications, and we can then switch to any model that we want under the hood. OpenRouter isn't the only application doing this, and there are alternatives like Grok or Together AI. But OpenRouter is the most popular, and in my opinion, it's the easiest to use when starting out. Today we learn how to use OpenRouter and also how to integrate it into our Java Spring Boot application so that we can switch between almost any AI model seamlessly. First, let's quickly see how to use OpenRouter. We can click here to see all the models that are currently available. For example, I can set a filter to only show OpenAI models. For each model, we can see the information about its context window and price. In almost all the cases that I've seen, the pricing here matches the price of the original provider, so you won't see any difference in cost. Now, to actually call these models, we will need to add credits. Once we sign in, we can go to the credit tab and top up our credits. Our credits will then be used on a prepaid basis. This is actually another good thing about using OpenRouter because some cloud providers don't allow you to prepay and top up credits and only work on a pay-as-you-go basis. This means that if you overuse the APIs by mistake, you'll end up with a huge bill at the end of the month. And this has actually happened several times. A credit system is better for smaller projects because you can prepay and you can be sure that you'll never be overcharged more than what you have already paid. Now that we have some credits, we need to create an API key. We can create an API key here, and once it's created, we can copy its value. We will use this key later in our code. Now that our OpenRouter setup is done, let's create our Spring Boot application. We can go to start.spring.io where we can initialize our application. I'm just adding some details here and leaving the default selected. For our dependencies, we will need to add Spring Web for building a REST API, and we will also need the Spring OpenAI starter. This is because even though we are using OpenRouter, the API provided by OpenRouter is OpenAI compatible, so we can actually access OpenRouter using this dependency. Finally, we will add Lombok to make it easier to parse our request and response bodies. Once we've selected all of these, we can generate and download our codebase. Now let's look at our Java code. If we open our pom.xml file, we can see all the dependencies that we've added. This includes the default Spring Boot dependencies along with the ones we selected, like Spring Boot Web, OpenAI, and the Lombok dependency. Next, let's look at our application properties file. This is where we will actually configure our application to connect to OpenRouter. We can paste the API key that we just created on OpenRouter over here. We'll also need to define the base URL as the OpenRouter API URL. Next, we'll define the model that we want to use. To get this value, we can go through the models on OpenRouter. And if there's a model we like, for example, Claude 3 Sonnet, we can just copy the model ID from the OpenRouter site and paste it into this configuration option. If you want to know more about all the configuration options available and what they mean, you can go to the Spring OpenAI documentation page, which I will link in the description. Finally, we set the server port, which is where we want our server to run. The application we want to build is a simple REST server. We have a REST API that accepts a prompt, runs it through the model that we have chosen on OpenRouter, and responds with the result. Let's walk through the Java code in our main application file. We've added the Spring Boot application, REST controller, and the request mapping annotations. The most important piece for integrating with Spring AI is injecting the chat model parameter here. This will be auto-injected by Spring Boot and use the configuration options that we defined earlier. We'll also create a logger just to log what's happening. The main method here will run the application. We've also defined the data transfer object for the request body that we will receive from our REST API. Finally, we have our REST API handler. Here we just call the chat model's call method with the message string that the user sent us via the API, and return the result as a response. We define the response here to just be a plain string. We've also wrapped this in a try-catch block to log any exceptions that may occur. Now let's see this in action. We can start the Spring Boot server by running the Spring Boot run command. This should automatically compile and run our code. Once our application is started, we can try sending a request. Here we are sending a post request to the API/AI/chat endpoint that we defined with a JSON payload containing the message that we'll send as the prompt. Here the prompt is to tell us a fun fact about the Python programming language. Once we send the request, our Java application should send this prompt via OpenRouter to our configured Claude model and return the generated response. So the response here is the one that's been generated by Claude. Now, a cool thing about OpenRouter is that we can see our usage stats in near real time. We can go to the usage page here, which shows all the API calls that I've made earlier and also the one that we made just now. We can reveal more details to see which model was called, how many input and output tokens were used, and the total cost and latency, along with other stats. So we can see that it was surprisingly straightforward to add OpenRouter into our Spring Boot application using the Spring AI dependency. The biggest advantage here is how easily we can switch between different models. For example, if you want to switch to Gemini 2.5 Flash, we just have to copy the model ID from OpenRouter and paste it into our configuration option. Now, any future API calls will use the Gemini 2.5 Flash model. This is incredibly powerful for experimenting, A/B testing, or adapting to new, better models as soon as they are released. One important thing to consider is that while OpenRouter and other applications like it add a lot of convenience, it is still an intermediary service between your application and the final AI model. So if you are using large-scale applications that handle sensitive data or are sensitive to security and privacy issues, you may want to keep this in mind. Despite this, I still think services like OpenRouter are great if you want to rapidly prototype or be flexible in switching models in a short time span. Thanks for watching, and I'll see you in the next one.